understand better how the Honeywell Brachma control work with the G44 printed circuit board and with the PLC. I don't have a Mercury controller, a Siemens controller, a Trend controller, or a Compre HX controller, but I have an old Omron controller, and this can work even with the Omron controller. The first thing to do, this unit will supply power to a supply fan, SF, then to the extractor fan, EF, which is a fan as well. And then if the DPS of the supply fan and extractor fan, they will send the information back into the BMS, which in our case is the PLC. So it will say okay, they both okay. So the fan start, the DPS sends the air flow, and it will say it is okay, because it's pointless to run a gas burner with tubes, a resonant gas burner, if the air is not trespassing the tubes. You'll overheat the system, but it's not even working because it is integrated onto the BMS. It can be integrated on a relay, but let's say it's integrated on the BMS. So number one will start the supply fan, number two the extractor fan, then the DPS will send the information back into the BMS. You will tell it's okay. After this, the BMS will send through another digital output, 240 volts, into this free voltage relay. You'll see it here. Let's assume that this PC board control have a power supply, live, neutral and earth. I'm supposed to use the appropriate color, right? So let's say I'm going with neutral, live, and I'm supposed to use the green one, which basically it is the earth. So that would be the earth. So we have all three. So this live will go through a small circuit breaker, and this will be the L1. And then this will be a constant supply, the neutral and the earth the same, will be a constant. Now we have already the power supply, so this board, it is alive. Now when the building management control, just have to make it better, not interrupt it here. Okay, it works, so brilliant. So when the extractor fan and supply fan works, the differential pressure switch sends a signal that it's okay. A signal to this controller will be sent by the building management control to this relay, which it is the output, I can't see very well, but I think it's 06, and it is this one. I want you to see it. I'll mark it up so you will see this one. So okay, so our power supply comes here and it's interrupted by this relay. Then you have another, you can run even two systems in the same time, but I'll explain to you. Now let's assume that one will go to a ResNAC controller. The power supply goes to L1 from this controller, and the other one will go to Honeywell controller, to number one. Let's give them numbers so we know what we're talking about. Number one, and this is number one too. So it's at number one. We know neutral will be a permanent supply. We don't even have to worry about this one. So the neutral, which is the number two, which is neutral, goes to direct supply. Here the neutral will be number 3. 3, it's our neutral, and this is our neutral, which is number 2. Every single burner is got its own characteristics. So we'll supply power to both. Say we have only one building management control, then we have 2 burners, but we have only one board which will supply power to 2 different units, because you can do this because they do the same building, and you can put individual thermostats for both. So this one will be only to control the alarms, the features. It is because it's got only one relay. You can't stage, you can run any stage, and so on. You can use this feature, but I will explain to you how a little bit later on. I don't want to go very complicated, so I will remove this Honeywell. Well, I think I will explain about both of them in the same time. The condition for this relay to close the circuit, it is to apply here 10 volts. It is 64 and 66. So you have to apply 10 volts. Dear friends, what I want to explain to you today, it's about how this controller works, the G44 PC board controller used in Resna burners, and how a Brachma controller works as well. And I just made a kind of virtual BMS, not with all function, just with the function I'm interested, so I can show to you how the system works when you investigate an air handling unit, especially the burners, because I will talk about this cooling system in another tutorial, how the building management control will enable compressors and so on. That will be a complete different history, but so far I just want to show you how this burner controller works, because some of my colleagues has been confused. I just want to make sure that they understand. This is the way PLC look like. This is an Omron Sysmax CP M2A. You can write a program in WinSys 3.4. This is quite an old program, but it's something that will really help you understand logic controls. I just have the privilege to have a course with ScanTime, and I've been explaining a lot of things, and that made me happy, because I accumulate a lot of information over the information I already had about controls. Coming back to our history, as you'll see here, and I hope you'll see it well, this is the building management control, I'm sorry. We have the status, we have the probes, we have the analog outputs, then we have the digital outputs, and then we have the power supply, because every single BMS have a power supply. I choose 240 volts because otherwise I had to make this drawing be complicated to put a transformer with a rectifier to convert the AC in DC, or some of them are AC, but that's not important today, because I'm not going to talk about building management control power supplies today. That's irrelevant. Now, what you'll see here, let's start with the beginning. Every time you go into a building and people will complain against the temperature, and will be asked to check why an air handling unit are pushing cold air, or doesn't work, or the fans doesn't work, they will tell you a lot of things. Obviously, if the building management control, it is like BACnet, you go into the remote data manager, and you will collect all that data, because you'll be able to read on the front on the screen panel all the information you need to know about this unit, if the unit is correctly and properly integrated, which is not the case, because I found a lot of mistakes. So let's say you're a very innocent technician which worked very hard. You can't trust the remote data manager because a designer was not very professional, maybe just a kid without experience in HVAC. He just put numbers to look more interested. QI, UQ, blah, 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 what they put in there anyway. The first thing to do, you have to check your own system. I used to have before a manual capabilities to override the building management control and to put the system on manual mode to check if my system works and to disregard the rest of the control. It seems to me that today, because of the economical situation, company are not allowing us to do this, and more you will find out that the manual switches are removed, leaving you with a massive level of frustration because you cannot run your system on manual mode to do your job, and then you have to make sure that you understand a bit of the building management control to see why the system is not working, or you have to make calls for the people which remotely control this to force the system running via the building management control. That's time consuming, and I really disagree with this. But let's start with the beginning. This PC board control, you'll find this a lot on Resna controller, but honestly works on many other controllers because from my perspective, this is a very simple unit. You will supply 240 volts on these little connectors. You go from 1 to 3, from the top to the bottom. 1, 2, 3, get a live, neutral and earth. Then you have a fuse here, which obviously you have to check if the fuse is alright. And these two are just free voltage relay, which will be enable and disable, and I'll explain to you how in a minute. You turn to the store for the first time, and one guy will show you where's the air handling unit, and bang, you'll find yourself in front of one of this system. Now, as a gas engineer and control engineer, you have to understand that there's safety features. I'm not talking about the ionization probe, because that will be the last thing to think about it. That's automatically will send incorrect information to the Brachma, which will cut the flame anyway. But I'm not talking about this. I'm just talking about the initiation protocol. The building management control, and I'm going to use red pen this time. So the building management control first have to enable the supply and the extractor fan, because it is pointless to start a flame if the air is not passing through indirect heater, because the flame goes through some tubes. They need air, otherwise they will overheat, and then the high limit will disconnect the burner and the flame will go off anyway. But that's not an appropriate way to do it. So first you have to start the supply and the extractor fan. If the supply and the extractor fan will have appropriate condition as per differential pressure switch set, then the differential pressure switch will send a signal back to this building management control, telling to the building management control that okay, the fan runs, we know runs because we have the right pressure. So as a DPS, we close the circuit, we send you the signal back, you can go further. In that case, the building management control already have a heat demand. As I put here, we have a heat demand. So if you have the heat demand, you obviously start the fans. So we have a heat demand. So the fan runs, the DPS and the healthy information, obviously have the heat demand. The building management control will enable and will put the system on standby mode. We'll send 240 volts to this free voltage relay. As I said before, we assume that this is already have the power supply, live, neutral and earth. It's powered up. This is not control. This has to be powered up all the time. So this is powered up. This is just a power to this PC board control. You can disconnect that one too if you want to play more safe to cut the power, but this is already ridiculous. You go too far, so I wouldn't go there anyway. But you can do it. You can cut the power, so you can link these two, and when you cut the power, to this relay, then you cut the power to the main printed circuit board, and then you save. I'll get there later on, because I have a video about that when I had some problem with some electrical failure inside the PC board control, and the PC board was constantly asking to this BMS to run. But even so, even if this one will ask to the BMS, to this Brachma, I'm sorry, the PC board controller will asking to the Brachma controller to run all the time, but it couldn't run all the time, because even if this board was asking and the relay was closed, there was no power here because it was held off by the building management control. I don't, because I will confuse you if I go so deep. All you have to understand, the fan runs, it's everything all right. Now the building management control will send the power to this relay. This relay it is an open circuit now, because it is not enabled. It is on standby mode. Then, because you have a heat demand, what you're going to do, and I'm going to use the red pen as well. You go with a signal. Just have to do it with red, and let's assume we have two cables here, and plus minus, and they 10 volts. So you'll come with this 10 volts, and you'll go with minus to 66, which is the last screw here. Please look, it is number 6 one, which it is 66. You'll go with minus here. I'm going to use the appropriate color, so you go with minus here. You see it's blue. I make it blue for you so you understand. And then you go with red one to 64, and then you have here let's see, 10 volts DC. Once you apply 10 volts DC and this board is sensing the 10 volts here, it will close this relay, and then the electricity will continue its journey straight to number 1 of the Brachma controller. As you'll see, please, because it's easy to see, it's number 1 of the Brachma controller. Now, the Brachma controller, it's also connected to neutral. I don't have to put a very fancy neutral, because the neutral, it's a neutral, will be directly connected to the neutral. So this is the neutral. Neutral, yeah, I have to do it again. I'm not very good Picasso. Neutral, and this is the 240 volts, 240 volts. 240 volts signal. That will supply the Brachma controller. Even if the Brachma controller got its power supply, it will not work, because if you remember on the other tutorial, in between number 3 and 7, and I'm going to put here number 3 and 7, I have to have a short circuit, and that can be done by a thermostat. Put this like that, an open circuit, and it's a thermostat. But honestly, it's not only the thermostat, because you can use another digital 3 voltage relay from the building management control to close this circuit, and the BMS can control the function of the Brachma controller. In this case, you don't need a thermostat on the wall. If you have a BMS, it will be shame to use a thermostat, unless you want, see this probe here, as you see this probe here will be used for another location, and the BMS have many other locations through the building and many heaters, and you want a special local controller because you want to heat this area. We're not going in there because it's getting too complicated. So this Brachma controller received now is got live and neutral, it's alive, and then this thermostat, it is open, so the Brachma controller is not initiating itself. So this board now have a 10 volts here, the power supply it's okay, 240 volts, and this relay is closed because when I applied the signal of 10 volts, this relay just closed the circuit and the electricity continues its journey, and the Brachma controller got the power supply, but I have an open thermostat. Now if I have the open thermostat, let's assume that we close the thermostat. So we close in the thermostat. If I close the thermostat, the Brachma controller starts the initiation protocol. How that happen? As you'll see here on my data tutorial, 11 and 12 will be the power supply. So I put here 12, so you can see it big, and 11 will be the power supply to a flue fan. Flue fan. The flue fan have also a differential pressure switch, which is number 10. I'm going a little bit sideways. So this is an open circuit. When the fan runs, will create a positive pressure. Positive pressure on a differential pressure switch, which have two little clear tubes that goes straight into the positive section of the flue, or negative. It's up how to the system it is designed. If it's negative, because you have two options on the DPS, one tube is on a positive side, one tube is on negative side, so you have to plug this accordingly. If the positive pressure it's okay, this switch will close the circuit. If the circuit is closed within specific time, then that means the signal goes back and the Brachma control will know that the flue fan, it is healthy, it's running, because if the fan doesn't run, you don't have a positive air pressure and then the switch is open. If you have a positive pressure, you have an air pressure, then the switch will close, and then the Brachma controller will know the fan is running. That's the witness. So we have the thermostat close the circuit, and then the fan start, the DPS close the circuit, which means the flue fan is running. Then after that, the Brachma controller will start igniting the system. So it will ignite the system, and when it will ignite the system, will spark here, will make like a zip, like will spark in between the spark plug and the earth, will have a little blue flame, and when it's got the little blue flame, the valve VG1 and VG2 will open, so you'll have a power supply at 14, 13, 18 and 19. You'll have the power supply and these two valves will open. When you open the valve, the gas will pass through this zap, through this blue flame, and the flame will come on. When the flame comes on, you'll hit the ionization probe, and if the ionization probe is okay, it will send an input to the Brachma controller, and the Brachma will know that we have flame. It's an electrical input, so it will be halfway rectified, which means through the flame you'll have an electrical impulse into the ionization probe, and that input will go back into the Brachma, and Brachma will know that you have a good flame. If you have a good flame, this is it. the system will run until the thermostat will disconnect this connection in between 7 and 3, and the Brachma will cut the heating protocol, will cut the heating. And then when the thermostat will enable again the when close the circuit again between 7 and 3, the Brachma know that have to start again the heating protocol, and it will start again with the fan, closing circuits, the zapper, the gas valve, and the ionization probe, and then the flame will go to heat the store again. This is it. It is not complicated. I'm not really sure with my Romanian English you understood too much, but what you have to know, I'm doing this for free, and I hope from all my heart that make your life a little bit easy. If someone will tell you that the Brachma controller is not running, you have to make sure you have power in between 2 and 1. You're supposed to have 240 volts, and in between 3 and 7 you have to have a closed circuit, because if you don't have in between 3 and 7 closed circuit, it means the thermostat is open or you do not have the heat demand. You don't necessarily have to have a thermostat. If you use a jump, you will run forever until it will pop out, maybe high limit, safety, blah blah blah. In between Brachma, this is a simple version. I just want to let you know that it is not so simple, because in between the this enable signal and Brachma controller number 1, you could have a lot of things. You could have, as an example, the high limit thermostat safety start. You have the high limit with manual reset, the high limit with automatic reset. You can have the fire alarm. You can have like a safety push button. You can, if you use a logic gate, you can use an AND situation for multiple safety devices, and only if they're all of them healthy, the system will work. If I speak for a classic environment, you can have in series with the signal hold the safety equipment, fire alarm, safety switch, all kind of protective gadgets you want to put into the system. I won't recommend doing this on the thermostat. I'd rather have it on a main power supply. So this is it so far, and just this is specific for some of my colleagues which do some combustion analysis, and they want to override the building management control. Sometime you can enable, because you have some little switches which overrides the signal that comes from the building management control right in here to this relay. What you can do, if you will have power here, it's enough to use a little jump here, which I don't recommend, and I'll explain to you why in a minute. And then the Brachma controller will initiate if the thermostat is in on heat demand, because sometimes you can have a lot of the building management control will hold off the heating in a building to save energy, despite the thermostat in the wall screaming for heating because the building is too cold. There's a lot of, there's a lot of illogical things which I always explain to my managers and to the people I work for about 10 years, but I'm not going to go there right now. One of the bad things, if you will do this little override, it is it will affect this, and I'll explain to you what is this. The gas valve you have two gas valves with two solenoids. Like, I'll try to make you to understand. You have the first gas valve, you have the second gas valve, so the gas passes through one, and here I have an actuator, and then the second gas valve, and then you have the burner, and then you have the flame here, and then obviously you have the tubes where the flame goes inside and is sucked by the fan, flue fan. Now, this actuator, it's controlled. This is the gas, yeah, gas. So this actuator of the gas valve, and I'll show you in a minute how the gas valve looks like. So this actuator, it is controlled by the first three connectors, as you'll see here. Is 61, 62, and 63. And for a couple of seconds, when the flame come on, the flame come very strongly, and then it lower itself, because this controller controls the high flame, low flame. If you will bypass this straight in here, you might either have high flame or low flame when you do the combustion analysis. So for you to have a proper design, I suggest that you make sure you have 240 volts right here, and then you have 10 volts here. And if not, you have to contact the people which controls the building management control. If you're smart enough, you can use a 9 volts battery to apply power here, and then if you have a potentiometer to drop down the power at 5 volts, then you can lower the flame. No building in 10 years, I never heard that anyone really cared about these little potentiometers on this PC board control, which tells you at what voltage you will enable the switch, and at what voltage will disable the switch, and what's the minimum amps that it will run. So no one really took care of that one. I tried to explain to my colleagues, but I'll leave it like this. The most important things for you is to understand how this is work. Thank you for having enough patience to listen to all my story here, and I hope you understood how this works. And if you'll understand this, I'll promise to you, you'll go to a resonant burner and you will fix it, because you will know what to do. Thank you.